Hello and welcome to Honors Function. In the second video in the series of linear equation, we're going to explore several forms of a linear equation. The first form we looked at is the standard form, ax plus by equals c. This is the most natural form to write a linear equation in two variables. I do not have any reason at this point to solve this equation for x or for y or to write it in a different way. Sometimes though you will see that the c is on this side and the equation is written like that. I am not adopting this way to do things. I mean, this is also very natural. It's just a convention. Okay, so I will put my c on the right. Now, the problem with this form is that it doesn't yield information directly about the line. If you want the slope, you know the slope is negative a over b. If you want the x-intercept, you need to set y equal to 0 and then you solve for x. And if you want the y-intercept, you set x equal to 0 and you solve for y. Okay, so it doesn't lend information readily. There are other forms of a line that will give us some direct information when we read them. Let's begin looking at one of these forms. Here is a linear equation. Again, you have two variables and each exponent is right. Therefore, it's a linear equation in two variables. And it's solved for y. Why do we solve it for y? Well, let's see. Let's get 2 points out of this line. So first I'm going to take x equal to 0. What is y if x is equal to 0? Y is equal to d. And actually right here, we already have one piece of information. This gives us the y-coordinate of the y-intercept. Don't forget, the y-intercept is a point, okay? So we read the y-coordinate of the y-intercept directly, and the point that I have right here is 0d. Now let me take, for example, x equals 1. Why not? I can take whatever I want, right? What is y? Y equals m times 1, so that's m plus d, and so the point is 1 m plus d. Let's now get the slope of this line. Now you know that the slope of a line by definition is a slope between any 2 points. I have 2 points on the line, so let me get the slope. So it is m plus d minus d over 1 minus 0. So the d will cancel and you have m over 1 or just m. And now we see we have a second piece of information, pretty important right here. We have the slope of the line right there. So when your equation is solved for y, you read the slope of the line and the y-intercept. This is called the slope-intercept form of a line. The slope-intercept form of a line. The slope-intercept form of a line is unique. A line has only one y-intercept and only one slope. I mean, if the slope is a fraction, of course you could say, you know, if x equals 2/3, then you can of course write it as 4/6. But 2/3 is equal to 4/6. Okay, so the slope-intercept form of a line is unique. The standard form of a line is not unique. For example, if you have 2x minus 3y equals 7, this is not the unique way to write an equation like that. For example, you can multiply both sides of this equation by whatever number you want. You would have 14x minus 21y equals 49. This is the same line, but you agree with me that the numbers are completely different. 2 is not 14, 21 is not 3, and 49 is not 7. We could also have negative 14x plus 21y equals negative 49. Okay, so the standard form is not unique, but the slope-intercept form is unique. Let's do an example. So in this first example, we have to find the slope-intercept form of the line going through these 2 points. This is an example that I have tackled in the previous set of notes. We know that the equation of the line is actually y equals 5. It has the same, the points are going through the same y, therefore the line is horizontal, right? You remember? Well, this is actually the slope-intercept form. It's y equals 0x plus 5, okay? This is your slope and this is your y-intercept. I'm gonna let you do number 2. Let's move on to another form of a line. In the second form, I will take a line with slope m and that goes through the point x1, y1. And I would like to find an equation for this line. We could, of course, try to get the slope-intercept. We can work it out and find the slope-intercept, but there is an easier way to write an equation of this line, and this is actually the most common way to write an equation of a line. Okay, so let's assume that the point xy somewhere on the line, anywhere on the line, right? A point xy is on the line. What do we have? The slope between x1, y1 and xy has to be equal to m. Let's just express that. So the slope between xy and x1, y1 is y minus y1 over x minus x1, and this slope has to be equal to m if this point is to be on the line. So let's multiply both sides by x minus x1, and we have y minus y1 equals m times x minus x1. And this, guys, this is called the point slope form of a line. Point slope form, and this is the most common way to write the equation of a line. It's the easiest. Is this form unique? No, it really depends on the point right here. If your neighbor has a different point, it will have a different point slope. It's also very easy from this form to go to the slope-intercept. You just solve for y, right? So you do y equals mx1 minus, I gotta distribute right here, mx1 plus y1, and here you would find your y-intercept right there. Okay, anyway, let's go over an example. Alright, number 3. Well, you know what? I'm realizing I really gave you a really boring point here to work with, because we know the equation of this line. This is y equals 5. And actually, this is not the point slope form of the line, really. The point slope form should be y minus 5 equals 0, you know the slope is 0, times x. And here it's really whatever. Let's use this point right here. Why not? X plus 1. But actually it's the same as 0 times x plus 10, x minus 13, or x minus root 3. Okay, it doesn't make any difference. This would be a point slope form of the line. Sorry about that, this is very boring. In class we will see more interesting points. I should have thought before cutting and pasting. Okay, let's move on to the last form. Please do this one. It's a little bit better than the one I just gave you. And actually, you will see right here, there's nothing to do but to write the equation, okay? All right, last form. This will be the last form, but before I explain to you why it's kind of interesting, although not very common, I need to show you that I can always write an equation in this form. So let me take my equation in standard form. For example, I'll do negative 3x plus 5y equals, and it doesn't matter what you have right here, I'll put 7. Here we go. Negative 3x plus 5y equals 7. So what's the characteristic of this form? First of all, you must have a 1 on this side. Therefore, you have no choice. You're going to divide both sides by 7 right here, right? So here we go. I divide by 7 both sides. What do I have? I have negative 3/7 times x plus 5/7 times y equals 1. And now I'm going to change the way the left side is presented, and that's very simple. For example, instead of saying that x gets multiplied by d, dx right here, x gets multiplied by d, multiplying x by d is the same thing as dividing x by the reciprocal of d, right? This is the same thing. So it's exactly what I'm going to do right here. I'm going to say that instead of multiplying x by 3/7, this would be the same thing as dividing x by negative 7/3. Okay? And here, multiplying y by 5/7 is the same as dividing y by 7/5. And you see, we get back to the form right here. This would be my a, and this would be my b. I need to make sure you understand that this a and this b have nothing to do with the standard form of a line. Okay? All right, so now, why is this a somewhat interesting form? Because look, suppose you want to figure out your x-intercept and your y-intercept. So let's go with the x-intercept first. So you set y equal to 0, right? And you solve. So if y is 0, this is gone, and you have x over a equals 1, so x equals a. So what's your x-intercept? It's a, 0. Okay, let's go fetch the y-intercept now. So you set x equal to 0, and you solve. Well, if x is 0, now it's this one, this term that is equal to 0. And so you have y over b equals 1. So y equals b. And so what is your y-intercept? It is 0, b. Okay, so now you see why this is sort of a pretty interesting form, because if, and it's a big if, okay, if your x-intercept and your y-intercept are really nice, graphing this line is straightforward. Go fetch a on the x-axis, suppose it's right here, a. Go fetch b on the y-axis, suppose it's right here, b. And then you just graph the line right there. Okay, so it's a very, very simple way to graph the line. It's actually, I guess it would be the simplest way if a and b are easily graphable. That's not a word. If you can easily graph them, okay? All right, let's go over some examples. For the last time, let's go over this very restrictive example right here. We know what this line looks like. It goes to the point 0, 5. So the y-intercept is at 0, 5. And so the equation of this line would simply be, there's no term x over a. That does not exist. Don't write 0 here, okay? That would be completely meaningless. So that does not exist. Therefore, it is y over 5 equals 1. Here we go. So it's really not interesting. I'm sorry I gave you the same horizontal line for all of these examples. I should have paid more attention. But I'm going to do 7, and you can do number 8 on your own. So in this case right here, we have to find a point slope form, and you know why a, right? Because you can have a lot of different point slope form. Then the slope intercept, there's only one, and the intercept form, I didn't tell you about this one, but it's obvious that you can only have one such form, okay? So here we go. Here's a line. So your point slope may not be the same as your neighbor, all right? Let's get the point slope. I need a point. Multiple of 2, multiple of 5, 1 away. Well, that's pretty okay. Let's take 4 right here. I want a 4 and I want a 5. And I want to be 1 away. So 4 minus 5 equals negative 1. So x equals 2 and y equals negative 1. 2, negative 1 will be my point, right? And so I also need my slope. All right, let's get the slope. The slope is negative a over b. And so negative a over b is negative 2 over 5. Here we go. Here's a slope. Here's a point. Here's a point slope form. Y plus 1 equals negative 2 over 5 times x minus 2. All right, here we go. That's a point slope form. That's here, number 1 right there. Number 2, slope intercept. Okay, well, let's solve for y. Y equals, so negative 2 over 5x plus, right here you multiply, right? Plus 4 over 5 minus 1. So it is y equals negative 2 over 5x plus, so what is this? Actually, there's a minus right here. This is 5 over 5, right? 1 is 5 over 5 right here, right? So minus 1/5. Here we go. Here's the slope intercept. Last one, the intercept form. So for this one, last one right here, number 3, I'm going to use this right here. I'm going to start with this, 2x plus 5y equals negative 1. And I'm going to divide both sides by negative 1. I'm going to divide both sides by negative 1 right here. Oh, negative 1, negative 1. So what do we have? We have negative 2x minus 5y equals 1. All right, so now let's write that. Let's write this product as a division. So x, instead of multiplying by negative 2, I divide by negative 1/2 plus y divided by negative 1/5 equals 1. Here we go. Here is the intercept form. Okay? All right, last part of the material. So this is going to be pretty short. We're going to be talking about horizontal line, and we're going to be talking lines, and we're going to be talking about vertical lines. So let's figure out how to write the equations of this kind of line. Well, we already worked plenty of time on the horizontal line, right? So let's do it a bit more generally. You take 2 points right here, AB for example, and I need a second point now. To ensure my line is horizontal, my y coordinates have to be the same, right? So if this is B for the first one, I need a B on the y coordinate right here, and it doesn't matter what I take right here, for example, C. Now you know the slope, B minus B over A minus C, the slope is going to be 0, right? And we know that, for example, if you use this form, y equals mx plus d, That's the y-intercept, and the y-intercept is going to be b, okay? The line is horizontal, the y-intercept is b, so the equation is y equals b, right there. That's the equation of a horizontal line, y equals b. I derived it in a previous example, okay? So I don't wanna linger on this one. And then what about the vertical line? Well, for a vertical line, you need the two x's to be the same, okay? So if my first point is a over b, right? My second point to be on a horizontal line has to be a, and then it doesn't matter what, c. Okay, let's get the slope right here. So the slope is c minus b over a minus a. That's a slope, m. Well, this is not defined, right? C minus b over 0. This is not defined. So this line has no slope. Well, how do we find its equation? Well, you have an x-intercept right here, right? That's a. Therefore, we can only use the intercept form. There is no y-intercept for this one. X-intercept is a, so I'm going to use the intercept form. X over a plus, well, there's no y-intercept, right? So this term does not exist, equals 1. And therefore, you have x equals a. Here we go. X equals a is the equation of a vertical line. Now let's try to understand these two equations in a slightly different way. Let's pick up the horizontal line. What does it mean? It means that y must be b, y must be b, and x can be whatever, okay? It's not restricted on the value of x. X is allowed to be whatever. There's only one condition about y. What does this equation mean? It means that x must be a, and y can be whatever, okay? It's not restrictive on the value of the y. It can be whatever. Y is anywhere on this line. It doesn't matter what, okay? All right, I'll let you do the last example, and I'm gonna stop this video right here. Thank you for watching.